This video covers question 5, part B of the 2022 AP Calculus AB free response section, no calculator allowed. I cover each of these different parts in their own separate videos because they're sort of their own separate little problems. So part B here wants us to write the equation for the line tangent to the solution curve at the point 1, 2. And then once we have that, then they want us to use that equation that we get to approximate what the value would be at point A. So this is a linear approximation problem essentially. Well, whenever you want to find the equation for a line, an equation for a tangent line, it's the same process. It's the same process you've been doing since you started finding equations for a line back in algebra. You're going to end up using your point-slope form to find out what your equation is. The point-slope form that I have memorized is y equals m times x minus x1 plus y1. I put the y1 onto the other side because guess what? That's where you're going to want it anyway. So why memorize something that has an extra step of algebra in it for you? Then as you look through here, the m is the part that changes from an algebra class to a calculus class. Well, to find your m, your slope comes from the derivative in a calculus class, your dy dx. Does that look familiar? Oh, it should, because there's dy dx up there. And then the x1 and the y1, that's the point off the graph. You'll get some x1, comma, some y1, and that's going to give you the point that you need to put this thing together. Well, the point on here is kind of given to us for free. We know our point. Our point is 1, 2. That's our x1, y1. The piece we have to go find is we need to go find our slope. So to do that, we're going to find our slope at that point. So they usually put like an evaluation bar. That's what that bar means. dy dx evaluated at the point 1, 2. So we come and use our derivative equation. That's what a differential equation is, right? Differential equation is just fancy math talk for derivative. And so I'm going to come and I'm going to plug in. Wherever I see an x, I'll plug in 1. Wherever I see a y, I plug in 2. So I get 1/2 the sine of pi over 2. And then instead of x, I've got a 1. And then the square root of, and instead of y in that equation, I have a 2 plus 7. So then we start figuring this thing out, simplifying it down. This would be 1/2 the sine of pi over 2 times the square root of 9. Figuring out the sine of pi over 2, that's where we got to go back to our unit circle information, right? So our points on the ends here, that's where we end up running into our different values. So pi over 2 would be right here. That is the point 0, 1 on our unit circle. And so why that's important is because those x and those y's, the x value comes from the cosine of the angle and the y value comes from the sine of the angle. So on this problem, we are looking to find the sine of pi over 2, which would be here, and that tells us that what we want off of that point is the y value. So we know that that would be 1. So starting to plug that in now, I would get 1/2. The sine of pi over 2 is 1, and then the square root of 9 is 3. And so in the end there, 3 times 1/2 gets us 3 over 2. This is our m now. That's our slope we need for our point slope equation. So let's put it all together now to get out the formula. So we get y equals m, so we're following our point slope formula here, which is 3 over 2, times x minus x1, which is 1, plus y1, which is 2. So there's the equation for our tangent line. Now we want to use that to approximate f of point 8. So f of point 8 will be approximately 3 over 2, and then instead of x, we're going to plug in what they want x to be in this, which is 0.8. So 0.8 minus 1 plus 2. On the AP Calc test, they actually will let you leave an answer like this right here because you've shown that you plugged everything in properly. You technically don't need to finish this thing out, but if you want to go through that process, you got to make sure you do it right. And so from there, we would multiply, you'd get negative 0.2 times 3 over 2 plus 2 would end up giving you out a positive 1.7 when all is said and done. And so that is also an acceptable answer. So you could have stopped here, or you could risk losing the point by finishing up and going there. This problem is a 2-point problem. You would have gotten 1 point for getting that equation of the tangent line correct, and then you would have gotten 1 point for getting out either 1.7 or this answer here. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.